here on the Radio Wammo Breakfast. Time now is 7:47 now.
100 billion other galaxies, each of which contains something like 100 billion stars. Think of how many stars and planets and kinds of life there may be.
Billions and billions and billions of stars. It seems like more and more research every other week coming out, talking about new discoveries in habitable, like Earth-like planets. But how much do we actually know about this kind of stuff? Well, Dylan Storey's been looking at some of it for us and collating some of the information. Thanks very much to the Auckland Stardome Observatory. Dylan, welcome to the show.
Good morning.
Of course, that was the wonderful voice of Carl Sagan launching our segment today. Can't get enough of the billions and billions, Dylan.
Yeah, he really had a great voice for conveying the gravity of these discoveries, didn't he?
It certainly did. But so this week, some thought that there are more of these kinds of Earth-like planets in the Milky Way than ever thought before.
Yeah, so in the sort of ongoing debate between is the universe teeming with life or is it in fact very rare, there's a series of new discoveries which sort of bring out some evidence on both sides of the argument. So, with of course the recent spate of planet finding, exoplanet finding, it's starting to look like there are more and more planets in the galaxy. So more than was originally thought. There's one piece of research which says that perhaps every star we can see in the night sky has planets around it.
Huh.
And this is, if we go back a little bit, this is stemming from a book that was published around the year 2000, I think, which was about the rare Earth theory, where it sort of described that life. It sort of said that life is probably pretty rare in the universe, and it quotes life requires an improbable combination of astrophysical and geological events and circumstances. So there's a lot of things that have to come together to make a planet with conditions like Earth. So life was probably very rare. But since then, we've had this spate of planet finding due to the new technology that's come about, new techniques, and it's finding far more planets than this theory envisaged.
Yeah.
And so a new article that's just come out is saying that there could be tens of billions of planets in the Milky Way, in the galaxy, because red dwarf stars, planets could be very common around red dwarf stars, which make up the bulk of the stars. So these aren't even the stars we see when we look up in the night sky. Red dwarfs are basically invisible. They're too cool. They're not hot enough to be seen from the distances that we see stars at.
The red dwarfs were like our sun, weren't they? But they've kind of expired.
No, you're thinking of white dwarfs.
Ah, okay. Explain that then.
Red dwarfs are just sort of, some people call them failed stars or only just got started stars. So the brightness of a star depends on its mass. I know how they feel, Dylan. I pretty much know how they feel. Yeah, same. Yeah. So the brightness of a star depends on its mass and the amount of material that's available. And red dwarf stars are just smaller. So smaller stars they don't burn as hot, they burn cooler. Mm-hmm. And so there are billions of these red dwarf stars all through the galaxy. And it's likely that many of them have planets around them, and the planets would have to be closer to be in the habitable zone because they're not as hot.
Yeah. But
new technology has started to discover those planets in red dwarfs' habitable zones. And so there could be, these stars, these planets that are closer to their star could have the potential to support life. We've also got an article that comes up about planets being discovered around ancient stars, so stars that are basically one of the first generation of stars formed in the universe as we know it. So stars are up to 13 billion years old.
Yeah.
And so the planet finding technology has discovered planets around these really old stars. So again, we're finding stars that are not just around planets, not just around stars like our sun, which was the first thing planetary scientists were looking for, but all sorts of stars. So this sort of widens the range of possible conditions that could exist on all these exoplanets, supporting the theory that the universe should be teeming with life. Even if only a small percentage of these planets has life, there still are just so many of them from the data we're getting in that the likelihood of life being plentiful is much greater. But then we also get another article, and on the other side of the argument, that is saying that researchers have found that tidal forces in planets within habitable zones may be likely to cause a lot of friction, heat due to friction within planets, which boils off any water in the planets, making life impossible. So perhaps there are these billions and billions of stars within the habitable zone, but perhaps it's more likely for a planet in the habitable zone to have its water squeezed out of it by these tidal forces.
Yeah, so that makes a lot of sense, doesn't it? So it's in this habitable zone, but it's got to be a lot closer to this red dwarf, big, basically, massive body right next to the planet. And we see what the moon does to our tides, and it's a whole lot smaller than what these red dwarfs are. So there's a lot of trade-offs here, isn't there?
There's a lot of trade-offs, and that's why it's so hard to predict what the conditions on these planets might be like. But yeah, our moon is a good example of tidal forces acting, because the moon is what we call tidally locked to the Earth. So that means it's close enough relative to the size of the two bodies that one side of the moon always stays facing Earth. So it twists around. When you look at the moon, you always see the same side of it.
Yeah.
You never see the far side of the moon.
That's where the Nazis live.
Apparently, yes, or insert alien civilization of your choice. But so a planet that's proportionally closer to its star, as it might be to a red dwarf, could be somehow tidally locked, so that perhaps one side could be facing the star, making life again unlikely. But the research says that, or the findings say that, planets with even a moderately eccentric orbit could have these tidal forces. So like Earth, it's got a fairly stable round orbit. It does move further and closer to its star, but it's basically round. But anything with a little bit more eccentricity, so a bit more elliptical orbit, might make life pretty unlikely.
We really are the lucky Earth, aren't we, Dylan? Just everything in this fine balance, just this perfect place where we are located right now around our star. It's quite extraordinary.
That's right. When you look at all the things that make life possible, there's a lot of factors that come together. But on the other hand, we have a sample size of one. The only planet that we know of that has life has these set of conditions. So it's notoriously hard to predict what sort of circumstances life could exist in. I mean, there's also the potential within our solar system that there could be life underneath the surface of some of the moons of Saturn and Jupiter. So if that becomes possible, then the search for life in the universe just becomes exponentially bigger. The potential places that we can look for life is just expands by orders of magnitude.
Well, in the meantime, we know that Dylan Storey is going to keep on top of this for us, and when they discover something new about this, then he's going to tell us at this time on a Friday. Twitter.com/Dylan Storey as well. Thanks very much to the Auckland Stardome. We'll see you next week.
Thanks, Wammo.